All right, Owls, this is Mr. O with your next set of flip notes. We are finally moving out of the waves unit. So we are on our third unit. So we've done matter, we've done waves, and now we are on to layers of the earth. Now let me tell you, layers of the earth gets a lot more simple, a lot more direct. The questions get a little bit more right there answers. So hopefully we will find this one and be a little bit easier for us as we go forward. There's the numbers from the state standards, so you know I'm doing my job. This is just based on layers of the earth. We will fill out the table of contents when we get to class. I haven't figured out what page number that's going to be yet, so I left that blank. But keep in mind, the beautiful thing about flip notes is you can pause the video at any time. If you have any questions, please write them down. And my expectations at the end of this, you should have your notes completed and then any of those questions written down, because if you still have these questions and you don't ask them, you'll never learn what you are confused on. All right, let's get started. There are 4 major layers of the earth, and you're going to use the handout I gave you in class and follow along with that. And the 4 layers moving outside in would be the crust, the mantle, the outer core, and the inner core. So you might want to label those on your table, but actually the next slide on the video is the table that you're looking at. We're going to talk more about these layers and what happens to them. So layers from the outside in. When I mean the outside, I mean it's what you're standing on. You are currently standing on the crust. You're standing on soil that's on top of the crust. And then underneath that is the mantle, and then you have the core that's separated in 2 different things, and there's a reason why they are separated, and we'll talk about those in just a second. The right side of this chart is called composition. And if you don't know, composition is what something's made out of. Now, you can get really technical with this, but in 6th grade, you have to know the basics. And what I mean by that, you need to know the crust is solid rock, and the mantle is liquid or semi-solid rock. The outer core would be liquid metal, and the inner core would be solid metal. So if you kind of look at this, I call it a sandwich, and it's probably not a great way to think about it, but it really is true. A sandwich has a piece of bread and some stuff in the middle, like peanut butter and jelly. And this is kind of like how that works, right? So the crust and the inner core are both solids, and we'll talk about why they're that way in a little bit. But the inside pieces of it are both liquids or semi-solids. They're not liquids like water. I mean, they're pretty thick, but they're liquids still. They're not solid. So yeah, that's the basics of composition for each of those. Now there's also 2 sublayers you have to learn about, and they are known as the lithosphere and the asthenosphere. Okay. And then the chart looks like this that you're looking at in your notes, and it has sublayer, lithosphere, asthenosphere, and then composition. Composition, like I said before, is what something's made of, and the lithosphere is made up of what's known as the tectonic plates, which is the crust and the upper part of the mantle, not very much of the mantle. And the asthenosphere is the spot just below the tectonic plates. Now they're called sublayers because they're parts of other layers. Lithosphere is parts of 2, and then the asthenosphere is just part of 1. But because they both have an important part on different things, and tectonic plates being the second part of this unit, the lithosphere will become more important there. And the lithosphere is the solid part, and the asthenosphere is kind of like a boat in water. And we'll talk more about that when we get to layers and plates. Let's move on to the thickest, thinnest, most dense, least dense. This is, you kind of got to know the layers of the earth that each get honored some of these awards. One of them gets honored with 2, and one gets honored with none. So let's look at this. The thickest layer is the mantle, and the thinnest layer is the crust. The most dense is the inner core, and we'll talk about why that happens in class. And then the least dense is the crust, and it's not ironic that the inner core, the innermost part, is the densest, and the least dense is the one that's on the furthest away from the center. It's because if you think about why we learn density, the placement of those would be based on density. And you can tell that the outer core does not get an award for anything, even though the crust got an award for 2 things. So keep that in mind. You have to know which one honors what makes them unique, and being the thinnest and the thickest and the most and least dense would make them unique. Let's turn your paper to the back of the thing, and first we're going to talk about convection currents. Now, convection currents, by definition, is a heat transfer in a liquid. It could also be in an air, but in this case, because we're talking about layers of the earth, we're going to be talking about how it works in a liquid. And then a convection current by itself, in definition, is a hot air rising and cool air falling in a circular motion. Now, it's ironic because we talk about the layers of the Earth, and the layers of the Earth are rather hot as you go down. So it's just the hotter liquid rises and the not as hot liquid rock or metal falls. So they're both hot. It's just one's not as hot, and then they will work that way. Convection happens when you boil water in different places like that. It also happens in our Earth, and we'll talk about what that causes in the next table. So the mantle and the outer core both have convection currents. So the inner core doesn't have convection currents. The crust does not have convection currents because they're both solids. Now the mantle and the outer core, because they're both liquids, have convection currents. Because remember in the previous slide that convection currents have to happen with the liquid or air. Now the mantle's convection currents cause the movement of plate tectonics, meaning why we have certain mountains and landforms and why earthquakes occur is because the mantle's having convection currents and it's moving the crust all over the place. Now the outer core, and we said it was liquid metal, because its metals are magnetic, it is one of the two reasons for the Earth's magnetic field. So the outer core is moving around this metal, which creates this magnets to be moving in a circular motion. And that is one of two reasons for the Earth's magnetic field. And then on the next thing down, you can look at, we're going to talk about the Earth's magnetic field. Now, people often think the Earth's magnetic field is based on gravity, which is not based on gravity. It's based on other things, but let's give you the two reasons for it, and then we can kind of briefly talk about what it is before we dig deeper into it with class. The first one is there's convection currents in the outer core. We just got done talking about that. The second reason why the Earth has a magnetic field around it is the Earth's rotating on its axis, and that's a big thing when we get to the space unit. But because we're spinning and we have metal spinning inside of us, it creates this magnetic force field around Earth. Well, what you don't know that this does, it actually protects us from a radiation given off by the sun, which could be harmful to Americans. Without the Earth's magnetic field, we probably wouldn't be on this planet because the radiation probably would affect us in a harmful, dangerous level. So be thankful we have the Earth's magnetic field. For some reason, people often think it's based on gravity or something, but it's definitely not a gravity thing. But we will talk more about the magnetic field in class. And the last thing, as you travel to the center of Earth, three things happen. A, you can't travel to the center of Earth, and we'll talk about how we know about it in class. But the first thing is, one, it gets hotter, obviously. Number two, it gets denser. You can tell that because the crust is the least dense and the inner core is the most dense. And number three, the pressure will increase as you travel down. Think about it. If you're watch a sporting event and the team wins and they all jump on the person, you don't want to be the person on the bottom. The person on the bottom is very much like the inner core because everything above it's pressing on top of it, increasing the pressure on it. But either way, write down any questions you have, and I'll be happy to answer them. And this is to be the intro to our new unit.